Okay, this is the other part of 2.6, which is operations on functions and composition. And this is going to be a short part. I'm going to try to make it short for y'all. So the first operation is the sum. So if we have something that looks like f plus g of x, what this is going to look like is f of x plus g of x. So literally just write the first function plus the second function. Now difference is obviously subtraction. So we have f minus g of x. That's how we say this. It's going to look like the function f of x minus the function g of x. If we have the product, which is multiplication, we have f times g of x. I don't know why I keep wanting to write 0. And this is just going to look like the first function times the second function. If we have the quotient, which means division, so we have f divided by g of x, we have the function f of x divided by the function g of x. Now the last one is something that could be a little bit new for you, which is a composite function. And the way that we say this, I'm going to write two forms. So we can have g, and we have this little circle which means of, f of x, which means write the function g, and then we have f of x on the inside of g where x would usually be. Now we also have f of g of x, which you can probably already guess what it's going to be. The function f of x with g of x on the inside. Okay, so I would write these down and then use them on our next couple of problems because I'm going to ask you what is f minus g of x, what is f of g of x, things like that. Okay, let's start with this problem, which is let f of x equal x squared plus 3x and g of x equal 2x minus 1, and we want to find f plus g of negative 5, f times g of 4, f divided by g of negative 3, and f minus g of 2. So when we have f plus g of negative 5, this is going to look like f of negative 5 plus g of negative 5. When we have f times g of 4, we're going to have f of 4 times g of 4. F divided by g of negative 3 is going to be f of negative 3 divided by g of negative 3. F minus g of 2 is going to be f of negative 2 minus g of negative 2. So let's go ahead and do these. You can use your calculator for this. So if we have x squared minus 3x, and instead of x, we have negative 5, we are going to have negative 5 squared plus 3 times negative 5. And we're adding this to g of negative 5. So we're going to have 2 times negative 5 minus 1. Now let's do some simplifying. Negative 5 squared is 25. We have 3 times negative 5, which is going to be minus 15, plus negative 5 times 2 is negative 10. So I'm going to change that to a negative sign. Minus 1, and let's go ahead and do the math for this. So this is all going to equal negative 1. Now let's do the next one, which is f times g of 4. I'm going to just write it below. So just make sure you keep track on your paper which one you are on. So we have f of 4, which is going to be 4 squared plus 3 times 4, and its multiplication. We're going to have 2 times 4 minus 1. Now, these are two quantities multiplied by each other, so we're going to have to use the distributive property, but don't use it quite yet. We're going to have 4 squared, which is 16, plus 3 times 4, which is 12. Then we have 2 times 4, which is 8, and we have minus 1. 16 plus 12 is going to be 28. Times 8 minus 1, which is 7. Okay, so our total is going to be 196. So that's the end of that part. Let's do f divided by g of negative 3. So we're going to have f of negative 3. So we have negative 3 squared plus 3 times negative 3 over 2 times negative 3 minus 1. And we're going to get 9 minus 9 over, and it doesn't even matter what it's over, right? Because 9 minus 9 is 0, so we're only going to get 0 back. Okay, let's do f of negative 2. So we have f of negative 2, which is negative 2 squared, plus 3 times negative 2. And then this is minus g of negative 2. So we have 2 times negative 2 minus 1. This is going to be 4 plus 6 minus, and still keep this in parentheses because we're going to have to distribute that negative. So we're going to want negative 4 minus 1. We're going to have negative 2 minus negative 5. So we're going to have negative 2 plus 5, which gives us 3. That is how you apply all of these operations. So now let's do some composite functions next. Okay, so let's remember or recall how we read these. So this means f of g of x. When we say of, that means it goes inside. So if we want to find f of g of x, we want to take f of x, which is x cubed, but instead of that x, we want to put g in wherever the x is. So let's write this in a different way. This is f, oh, sorry. Okay, this is f of g of x. So we want to put the g of x wherever there's an x. So instead of x, we're going to write x squared plus 3x minus 1, and then we still have it cubed from this original function. So this is the same function, but instead of an x, we've written g of x in parentheses. Now you could take this and apply the distributive property, but if you write this exactly this way, that's perfect for me. Just make sure you write f of g of x equals this. Now we have g of f of x. So g of f of x, this is also written as g of f of x. So we want to write the function g of x, but wherever there's an x, we want to write the function f of x. So we're going to have x cubed, and then this is squared from this one, and then we have plus 3 times x cubed minus 1. So let's simplify a little bit. When we have our exponents on the outside of the parentheses, we're going to multiply them. So we're going to have x to the 6th plus 3x x cubed minus 1. Okay, now let's find f of x. So f of x is also written as f of x. So everywhere there's an x in f of x, we're going to go ahead and plug f of x back in there. So we're going to have x cubed, and that's cubed again, which is going to be x to the 9th. These would be your final answers. However, we also want to find the domain of these. When you guys see that you have to find the domain, I literally just want you to plug it into your graphing calculator and look at the domain. If you look at these on your graphing calculators, you're going to see that the domain of this first one is negative infinity to infinity. Remember, you're looking x-wise where the function can be. This one's going to be negative infinity to infinity, and the last one's also going to be negative infinity to infinity. If your graphing calculator does not show that, please come get some help from me. I'll show you. Okay, that's the end of 2.6, so if you watched this and also the other 2.6 video, you're good to go for all of the problems you have to do on 2.6.